You're a printing equipment manufacturer and you set up these several $1 million worth of equipment in a print shop. You want to make sure you got spare parts for the next 20 years because you don't want to have your multi-million dollar equipment shutting down because one power supply is no longer available.
Okay, so I would like to get into a couple of case studies. Can you share a story where you had a very complex or challenging lighting problem for your customer, and how did you solve it?
Okay, so give you one example. When you have magazine and newspaper printing, let's say magazine, you have these beautiful, colorful magazines, and they are produced in high-speed machines. One of the key elements to let these high-speed machines work is that after the wet printing, the color is dried very, very quickly so that you can roll up the paper without leaving a mark on the next one. So this is done with long UV lamps with very, very high power because you have to dry very, very, very quickly. Several thousands of watt. But because you're moving the paper with several tens of kilometers per hour below the light.
Like on a conveyor belt? Right?
Yes, like on a conveyor belt, yeah?
Yeah.
You want to have a very, very stable light because if the light would have some ripple, you would see the ripple in the color by the speed of the paper going underneath. So, for this application, our partner, whom we support with components and work together on that product, they developed a power supply that is operating at several tens of kilohertz, between 40 and 200 kilohertz, depending on the power needed. Also has to be adjustable because if the conveyor light stops, you want to lower the light immediately. And it had to have a light deviation of less than 1%.
Meaning it had to be very stable.
Very exact, yes.
Yeah.
And that was done with a very advanced control circuitry with feedback cycle. I cannot go too much in detail because this is under the IP of my partner, but we had to develop special components, power supply components, that can make that work. And this is a constant feedback cycle between the application, light source, the output, refining of a design, implementing it. Okay, and then if you're a printing equipment manufacturer and you set up these several $1 million worth of equipment in a print shop, you want to make sure you got spare parts for the next 20 years.
Right.
Because you don't want to have your multi-million dollar equipment shutting down because one power supply is no longer available. So when it comes to those applications, it's not good enough just to solve that one problem now. You also have to consider what will be the needs of your customer for the next 20-25 years. Now, the electronic industry typically does not give you a guarantee to offer components for the next 20 years. Yeah? Or when did you see the last 386 processor for a computer, right? You can't buy that anymore. We all have different processors right now. So when you come into a design of a product, you have to think about the interfaces so that you can have a stable interface for many, many years. Although inside the technology, you have to, we call this sustaining engineering, you have to adapt to newer parts which are available every couple of years, but maintaining the same mechanical, electrical interface to the machine. Because that machine is probably going to run much longer than the electronic components are going to be available.
So in this case, you actually helped your customer to source not only to build the light source, but then to actually have the maintenance components.
Yeah, we have to, exactly, we have to already consider in the design of the original product, we have to think about the supply chain for those service parts in the long term.
Right.
And because, like for instance, to give you a nice example, medical equipment. When you have a surgery and there is minimal invasive surgery, where they basically drill 2 holes into your body. One, they put a fiber in to eliminate the tissue, and the other one, they put the tools in, and then they start cutting your vessels.
Jesus.
Yes, and now the surgeon, they want a light source, which is relatively sunlight, so it has the same light spectrum as the sun, but does not heat up the tissue, because you don't want to inflame the tissue. And then the other hole, they have the little scissors and little tools to pull on the things. Can you imagine you're lying on this surgery table and they have this fiber going into your body, the other one, the power supply is on the bench outside the surgery room, and suddenly you hear a sound, poof, you have smoke going off, the light goes off, you have the scissor in your body, and that's not a very pleasant experience.
That
right?
sounds like a nightmare.
Right? So the quality of that power supply in that light source is very, 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 very important.
Yeah.
Yeah, it's about the life of the patient.
It's life and death, yeah.
Yes. So we are also supporting applications like those. So and in these applications, the best cost is not the primary objective. The primary objective is you have a reliable product. Now, this equipment, the medical equipment, of course, we have to go under FDA and all those certifications. The certification costs of making such equipment way exceeds, or is a major part of the development cost for such equipment.
Wow.
You need case studies, you need to prove it, you need to have certification, the FDA will visit the manufacturers, they will look at the supply chain and all of those things in order to deliver that level of confidence that you can use reliably. I mean, as we just learned recently in the news, USA has a big plane manufacturer. They were facing some quality issues for some materials, right?
Yeah.
Yeah, you don't like to fly in a plane where the door flies out and you get a fresh air at a couple thousand meters on the way. You just don't want to have that, right?
Yeah.
So it's not good enough for that one just to have the best price. You want to make sure that this is tested and tested again and verified and done right.
And you are walking your customer through this entire process, even the verification, certification.
We cannot do everything, but we are supporting that. But most importantly is right in the beginning or through the process to identify the important needs and the not so important needs. Coming back to the Walmart, what is the most important need? Everyday low prices.
Right.
Right?
Yeah.
So their needs are different from the power supply that a surgeon is using, or the light source for like in a plane where they have these red lights flashing on the wings to indicate where they are.
Yeah.
The needs are quite different.
Right.
And you should know them when you go into those applications.